Hello, and welcome to I Know Dino, the Big Dinosaur Podcast, where we cover news, interviews, and discussions of all things dinosaur.
Hello and welcome to I Know Dino. I'm Garrett.
And I'm Sabrina.
And today's podcast is brought to you by the Royal Tyrrell Museum, which is located in southern Alberta, Canada. It's one of the top paleontological research institutes in the world. The entire museum is dedicated to the science of paleontology, and it's definitely a must-see for every dinosaur enthusiast. More information can be found at tyrrellmuseum.com. This week, we have an interview with Dr. Victoria Arbour, focusing on ankylosaurs.
Garrett's favorite.
Yep. We have the dinosaur of the day, Homalocephale.
Also known as Prenocephale.
Yeah, it's one of these is one a juvenile situations. And we have a bunch of dinosaur news.
Before we jump into that, though, we just want to give a big shout out to our patrons on Patreon. Thank you so much. And as you all know, if you've been listening the last few episodes, we're running a special promotion on our Patreon to celebrate our upcoming 100th episode. So from now until October 21st, if you pledge $1, then we will do a shout out of your name in a special video that we're doing for our 100th episode. If you pledge $2 or more per month, then you can leave us a voicemail and we'll include it in our special 100th episode. Plus, we'll also do a shout out of your name in the video. If you do $5 or more a month, then we'll send you a personalized postcard from SVP where we will be celebrating our 100th episode. Plus, you get the $1 and $2 bonuses. If you do $10 a month, we'll make a special personalized video for you from SVP and we'll send you a postcard, plus all the $1 and $2 reward bonuses. And if you pledge $20 or more a month, you will blow us away with your awesomeness. And you can pick one of our dinosaur books that we've published. We'll send you a signed copy. Plus, we'll do the special personalized video and send you a postcard from SVP. And you get all the $1 and $2 level bonuses. So, you have until October 21st. Pledge now at patreon.com/iknowdino.
Yeah, and that's Patreon is how you spell Patreon. So jumping right into the news, there's a new study that kind of looked at how dinosaurs looked depending on their size. And when you think of a Dilophosaurus, you probably think of the head crest that it had, and hopefully not about the frill that it probably didn't have. And a group of researchers set out to figure out how skull ornamentation might have been linked to dinosaur evolution. So Dilophosaurus was actually pretty big. It was a lot bigger than the one in Jurassic Park. It was one of the biggest predators in its time, which was pretty earlier in the dinosaur reign. But interestingly, the researchers found that dinosaurs that had crests or horns on their heads, like Dilophosaurus, or to a lesser extent T-Rex, grew to larger sizes than dinosaurs that didn't have skull ornamentation. So they looked at maniraptorans, which are the likely ancestors of birds, and other theropods, including tyrannosaurs, and they found pretty consistent results. So the results were especially significant at the extremes, with 20 out of the 22 largest theropod dinosaurs showing some sort of skull ornamentation. Meanwhile, they didn't see any skull ornamentation on dinosaurs under 36 kilograms. So that kind of shows you the extremes and how the ornamentation worked out. But you might think, what about those other two large theropod dinosaurs? The researchers believe that maybe they used feathers for display instead of crests or horns on their head. And then the lead author Gates said in a phys.org article, quote, "Something about their world clearly favored bling and big bods," end quote. So basically he's saying that it's hard to say if these are causative or if it's really just a correlation is all we can tell right now, that they had a lot of ornamentation and they tended to get really big. But it's definitely interesting that these bigger ones had more bone ornamentation. I guess you'd call it skeletal ornamentation.
Just go with bling.
Yeah. Well, the smaller ones might have had bling too, but it could have been things like feathers.
Wasn't flashy enough.
I guess. Yeah. I think feathers are probably more exciting, but
maybe.
They don't fossilize well, so it's hard to tell.
Millions of years later, yeah. Next, Eromanga Natural History Museum is raising money via the crowdfunding platform Chuffed to 3D print replica dinosaur legs of Cooper, which is the titanosaur that was discovered there in 2007. This is according to ABC. Cooper is about 98.5 feet or 30 meters long, and we've talked about this museum before and how it only opened in March in Queensland, Australia in the outback. The museum has helped out its town during a long drought by providing jobs, and so now their goal is to raise $40,000 to get the bones 3D printed by a company in Sydney, and the hope is to reach that goal by the end of the year. And we'll post a link to Chuffed on our blog, so if you feel like donating.
Cool.
Next, there's a lot of people who make videos, but Jack Lewis, who's a British firefighter, specializes in dinosaur impressions. He's got 2 videos, one where he acts like a T-Rex and one where he acts like a velociraptor. So what he does is he walks around like the dinosaurs. He actually does a really good job mimicking them. And his sounds are spot on, at least compared to Jurassic Park dinosaurs, which is also impressive. Because if you think about the number of animal sounds they mix to make those sounds, and then this guy's just doing it.
Yeah.
And as the velociraptor, he jumps up onto the table and chirps to his fellow velociraptors. It's very entertaining. So we'll be posting a link on our blog. Next, thanks to Matt, who shared this one with us via Twitter. According to North Devon Journal, there's a sculpture of a naked woman riding a 19-foot Struthiomimus. Andrew Sinclair created the sculpture, which is worth £50,000, and was recently moved to the McInnes Golf and Country Club in Wales, so it could be on a TV show and celebrate the club's 10th anniversary. The sculpture is known as the prehistoric sculpture. Apparently, Andrew and his sculpture school, which he runs, are not allowed to say which TV show the dinosaur will appear on, so we'll have to keep an eye out.
Yeah, I'm guessing it's probably on the BBC, though, based on
being in the UK.
Yeah.
Yeah. But still.
Thanks to Patrick for sharing this with us on Facebook. There's a new set of LEGO Jurassic World shorts on YouTube, and it's titled LEGO Jurassic World: The Indominus Escape. I don't want to spoil any of the plot, but it's pretty funny. They're on YouTube as 5 short videos, which combine to make about a 24-minute long story. Everything looks pretty much the same as the LEGO Jurassic World video game, but the voices are different from the film and the game. It's got that same slapstick-style comedy that LEGO always has, and obviously lots of LEGO dinosaurs, so if you're into either of those things, check out the link in our show notes on iknowdino.com.
I'm into those things.
Yep.
All those things.
You sure are. I'm into some of those things.
I love the LEGO slapstick comedy.
It can be pretty funny.
It's very whimsical.
Yeah.
Next, thanks to Phil, who shared this one with us via Twitter. Tapate Driftwood Creations showed a sneak peek of a couple raptors that will be going on display at an event at the Auckland Botanical Gardens in November. During the event, attendees will have the opportunity to buy the raptors, though there's no public details, at least that I could find, about how much it costs and the size of the raptors. Greg Maddox is a sculpture artist who made these raptors, and he uses driftwood to sculpt animals. We'll post a link on our blog so you can see the picture. It's pretty cool.
Yeah, that's really cool. I like the idea of using driftwood to sculpt dinosaurs.
Mm-hmm. And next, thanks to Patrick, who shared this one with us via Facebook. 2000 AD did a cover reveal on Facebook of Prague 2001, and the cover has a giant T-Rex that looks like it's about to eat a group of fighters, and these fighters mostly look like cowboys. There were a couple other ones. They're not cowboys, but they're silhouettes, so it's hard to say what they are. We're not too familiar with the series, but the cover looks intense, pretty much black and white, and awesome. And Prague 2001 came out on October 5th. If you want to check it out, we'll post the link.
And lastly in the news, we have more Jurassic World stuff going on, as per usual. Apparently, Colin Trevorrow won't be directing Jurassic World 2 because he's busy with Star Wars Episode 9, but instead it will be directed by Juan Antonio Bayona, who is known for a few horror movies, and apparently the plot of Jurassic World 2 works well with his skill set, meaning horror. So we're expecting to see a scarier movie, and it's also supposed to focus less on the militarized dinosaurs, and will probably have less of a fast-paced action sort of style, and instead have more suspense. And Trevorrow has also said that there may be some new animatronic dinosaurs in Jurassic World 2, since that's more of Bayona's style, and it fits better with the storyline that they've crafted, so they've kind of built it around his skill set a little bit.
Yeah, I'm excited about that.
Yeah, it should be a pretty intense monster movie, it sounds like.
Yeah.
Now I'm really expecting everybody to have like little baby dinosaurs in their house, and then they all get attacked.
Oh. We'll see.
But yeah, like iRobot style, where all the robots turn on them. But this time it's cuddly dinosaurs.
Not so cuddly if they're turning on you.
That's true. And now let's jump into our interview with Victoria Arbour. Victoria Arbour is a postdoctoral fellow at the Royal Ontario Museum / University of Toronto in Canada, and she's one of the world's leading experts on ankylosaurs, which is why I really wanted to talk to her. So, personally, my favorite dinosaur is Ankylosaurus. Is that your favorite dinosaur too, or do you like a different ankylosaur better?
Oh, it's hard to decide because I like a lot of them a lot. But Ankylosaurus is definitely cool. It's definitely one of my favorite of the ankylosaurs. Yeah, I'd be hard pressed to pick a very favorite one because I can rattle off like cool things about a whole bunch of different ones.
Very cool. Yeah, your bio on the University of Alberta says that you've identified 4 new species of ankylosaurs before you got your PhD. Is that true? That seems too incredible to be possible.
Well, it's kind of true, although maybe I need to update some of those things. So one of the projects that I worked on while I was a PhD student at the University of Alberta was taking a look at the diversity of ankylosaurs in Alberta especially, but sort of broadly in North America and Mongolia. And one of the ankylosaurs that's one of the best known ankylosaurs is called Homalocephale. It might not be a really easy name to say, but most ankylosaur toys are actually Homalocephale, not Ankylosaurus. So it's like a really common one to see reconstructed, but they often just call it Ankylosaurus instead, even though they are different animals. But I can't really blame them because it's not a really easy name to say. So this is one of the dinosaurs one of the ankylosaurs that we have the most specimens for, but it also has like a really long stratigraphic range. So it has sort of a long like time range that it was found in. And the more that we learn about Alberta dinosaurs in particular, the more that we know that they tend to have relatively restricted stratigraphic ranges. So we find them sometimes just in one part of a geologic formation, and not very often do we find them in more than one geologic formation within Alberta. So that's pretty cool. So I took a look at whether or not all of these different specimens that we were calling Homalocephale actually were all one species, because there was some variation, and I wanted to know whether or not that was just like normal variation within a species, or whether or not it maybe had to do with growth or sexual dimorphism, or even just squishing during fossilization.
Mm-hmm.
So some of the work that I did actually I didn't name new species, but I resurrected old species that had been lumped in with Homalocephale.
Okay.
So there actually had been a couple of different species named from Alberta. And back in the 1970s, another really prominent ankylosaur researcher, Walter Coombs, decided that probably all of those represented one species. But now with this new framework of looking at dinosaur species richness in Alberta, I was able to find that we had actually 4 different species had been lumped in with Homalocephale. So that was really fun. So we had an animal called Dilophosaurus, which is represented by a pretty good skeleton at the Royal Ontario Museum, and it has a really skinny tail club. Anodontosaurus, which is found in younger sediments than most of the Homalocephale specimens that are found in Dinosaur National Park, and has a really cool pointed axe-like tail club. And Scolosaurus, which is known from a really great skeleton that's on display at the British Museum of Natural History that has skin impressions and all of its osteoderms in the face, which is really cool. And it's also known from specimens from Montana, so it's one of the few that kind of crosses the Alberta-Montana border. So I didn't get to name those new ones because they already had names, but I did get to show that they actually were distinct and that we actually had a much greater diversity of ankylosaurs, and that not all of the variation that we saw in Alberta was just like intra-specific variation, that it really was different species. So that was a really fun project to work on.
Yeah, that sounds really cool. So when you're doing that kind of research, where did you come up with the old species names? Were they all those specific ones had been previously identified with different species names and then lumped back together under the same species? Okay.
Yeah, it's kind of a funny story. We don't really talk about sort of synonymies and resurrecting old names because it's easier to talk about new names, like identifying a new species. But back when a lot of Alberta dinosaurs were being named, it sort of was like every new specimen got a new name. And then as people found more and more specimens, they would look at things and be like, ooh, I'm not really sure that these are all that different. There's a lot of variation. We can't have like 30 different species of ankylosaurs in like 2 million years in Alberta. So maybe all of these are really just one species. But like I said, now that we've sort of got like a new framework for how we think about species and how we understand their distribution in Alberta, we have a much better sense of that there's kind of like different like cohorts of dinosaurs. There's different sort of groups that get found together at the same time, and then they kind of shift and we get a new group of dinosaurs, which is pretty cool.
Gotcha. So it's a little bit of splitting after a whole bunch of lumping.
Yeah. And taxonomy is really fun. I really like doing it. I like figuring out what species we have. But it's always changing too, because new specimens can give you new information that make you look at things in a new light. So I think it's one of these things that's always a little bit in flux, even though you kind of want it to stay stable as much as possible.
Yeah. And I think at that level where you're looking at whether they're different species is a little bit easier than the whole, like, should they be in the same genus or not? I've been reading a bunch about that, and that is such a mess trying to define what a genus is.
Yeah, it's really tricky. So what I did in my project was I brought back all the old genera, all the old genus names, because I didn't want to make something really complicated called new combinations, where you like take a new genus name and take an old species name and put them together and make sort of like a whole like hybrid name out of everything.
Mm-hmm.
And the definition, what a genus is a little bit flexible, and especially different taxonomists working on like very different groups will have sort of different concepts of what makes a genus versus a species. So if you work on beetles, your idea of the amount of differences that you need to call something a different genus rather than a different species is quite different from what dinosaur paleontologists use. But that's okay. Everybody sort of understands that there's a little bit of flexibility in there and that it's not really a hard and set rule. So the main thing is that we try to be consistent within our own groups and just kind of recognize the work that we're all doing together.
Nice. So as far as when you're saying an ankylosaur, that's actually a level up from a genus, right? Is that like a...
Yeah, it's actually a couple levels up from a genus, depending on how many levels you like to recognize. So one of the things, so ankylosaurs are a pretty big group of dinosaurs. They're not like the biggest group. They're not quite as diverse as, say, like the ornithopods, that things that include like duck-billed dinosaurs and iguanodon and all kinds of interesting creatures like that. But they are pretty diverse, and they kind of have two main groups. There's one group that's called the nodosaurid ankylosaurs, and that group never evolves a tail club, that kind of cool like axe structure on the end of their tail. But they often have like really big shoulder spikes. They keep the sort of long snout that early ankylosaurs had, and they're pretty cool animals in their own right as well. The other main group are the ankylosaurids. Those are the ones that I've spent most of my time with, and that's the group that eventually evolves a tail club. They tend to have sort of a squashed snout, a more sort of bulldog kind of face. They don't have as long a snout as nodosaurids. So that's sort of like the two main groups, and most of the ones that I've worked on are in that tail club group.
Cool. So speaking of tail club evolution, I read your paper on the tail evolution, and it's one of my favorite papers. And you talk about how they went from a flexible tail in early ankylosaurs, and they got a stiff tail a little bit later with some fused vertebrae. And then you had the club eventually forming with osteoderms at the end of the tail. So I was kind of curious when I was reading this, just how useful having just the stiff tail without the osteoderms on it would be. Would it be kind of like having a bat or something on a tail, or?
Yeah, that's how I like to picture it. To me, that's one of the most interesting questions, is that we seem in the fossil record to have this pattern, like you said, where the tail becomes stiff well before they get like a really large ball of bone at the tip of their tail. So they have osteoderms that go down the tail, but they probably like tapered all the way down to the tip, and then only much later do they get that sort of huge, like massive ball of osteoderm at the end. So I kind of picture having just the handle, sort of the handle of the axe, the handle of the tail club, is a bit like having a baseball bat on the end of your tail. So maybe it's not quite as effective a weapon as having that full axe head on it. But, if someone's chasing you around with an axe or chasing you around with a baseball bat, you're going to probably run away from both of those things, even if, like, a baseball bat can't, like, chop your leg off or something. I guess not to be too grim there, but I don't want someone to like smash a baseball bat. So yeah, so I think it could have functioned like that. I haven't done any biomechanical studies of what an ankylosaur tail with no sort of knob of bone at the end, how it would function. But I think that's a really cool area that we could look at in the future and try to understand sort of like the function and biomechanics of sort of these half tail clubs.
Yeah, because you did write a paper about the biomechanics of a tail with the club, right? And you kind of showed
That's
that.
right.
What was the conclusion you had there? I forget exactly what you learned.
So what I was trying to test I have sort of a pair of papers, one where I do some mathematical modeling to see how fast and hard an ankylosaur could swing its tail. And then I took that information and used finite element analysis, which is like a special engineering technique where you can apply force to a digital model of whatever you want and see what happens to it when you, say, smash it into something. Mm-hmm. And so what I wanted to know was whether or not ankylosaurs, or ankylosaurids specifically, could even like wield their tail clubs with any sort of significant amount of force. And then more importantly, whether or not they could withstand that estimated force without breaking. Because if they can swing it really fast and hard, but then it breaks as soon as it touches something, probably they would not have used their tail clubs in that way, because that seems like poor design. Mm-hmm. So yeah, so the thing that I did was I also modeled sort of a range of assumptions. So it's really tough in some ways to do some of these biomechanical analyses because we don't have like the muscles and the soft tissues that really influence how animals move, especially in a tail where there's lots of different bones and lots of muscles that help move the tail in many different directions. So I used a range of different assumptions, like how much muscle there would have been on the tail, different sort of rates of muscle contraction, different like masses of bone and things like that. And we also have different sizes of tail clubs. So some tail clubs are quite small, maybe only like 15 or 20 centimeters wide, but then some are really, really massive. The biggest one I think I've ever measured is about 61 centimeters wide.
Wow.
Which is really big, especially when you consider like the volume represented by that as well. They are really heavy, and I'm not totally even sure like how an animal keeps something that heavy up off the ground when it's so far away from its body. I think it has a lot to do maybe with the tendons that they have sort of ossified tendons that run along the tail. But I'm getting off track here. So the thing that I wanted to know was whether or not they would break under those estimated forces that I did. And the short answer is probably not. The longer answer is it's really hard to tell sometimes. So under some of my modeling assumptions, the really big tail clubs would break under like the highest impact forces. But under the sort of more conservative estimates that I did about impact speed and mass and all of those fun things, they probably could withstand it. The tail clubs were pretty good at dissipating the stress through the knob and through the handle of the tail club. And maybe only the very biggest ones, if they hit them really hard, would actually break their own tails.
So how fast did you think that they would be swinging these tails? Was it just like as fast as you'd need to break something, or
I think it would really depend. I think that for some of the really big ankylosaurids with really big tail club knobs, I think that probably would have been like enough of a visual signal to opponents not to even approach. In the same way that, like, for example, a lot of like heavily armored animals today, like porcupines, like a lot of animals won't even approach those. They're just not prey, and they're not, bigger deer with bigger antlers kind of intimidate smaller deer with smaller antlers, and they don't even have fights because they've got a signal there, a visual signal that says, I'm going to win, and you will lose. So I think that some of the ones with these really huge tails probably didn't actually even use them a whole lot if we kind of think about them like modern animals. And then for some of the sort of like more reasonable sized ones, say the ones in the sort of 40 centimeter range, I'd have to look. I always forget exactly what the impact velocity and impact force exactly is, but it's a lot. It's enough to break bone, definitely. So if an ankylosaurid tail club smashed into like a theropod ankle or maybe another ankylosaurid's ribs, it definitely would have cracked that bone. That's how much force is behind them.
Yeah, that's a good measuring stick to have. If it's strong enough to break bone, you might not even go near it.
Right. Yeah, especially like thin bones like ribs and like ankle bones, I think would have been quite vulnerable.
Yeah, I think that's actually why I like Ankylosaurus the best, because it's kind of like one of those pacifist animals. Same, my wife and co-host Sabrina loves sauropods, I think for the same reason, where it's like, well, it's so big, everything just leaves it alone.
Yeah, so I think that's very true. I think in particular, a lot of ankylosaurs were probably using their tail clubs mostly against each other, really. When we see like weapons in most modern animals, weapons are really for fighting members of your own species. A lot of weaponry evolves through sort of male-to-male combat. And interestingly, often when you need to defend a resource. So that seems to be the driving sort of selective pressure in modern animals that evolve weapons. It's almost always males guarding some sort of resource related to reproduction. So there's really cool research out there, especially on beetles, scarab beetles, rhinoceros beetles, where the males are defending burrows and sort of using their weapons to sort of shove other animals, like other members of that species, away so that they can mate with the female that's in that burrow.
Yeah.
So that seems to be the main reason that weapons evolve. So certainly weapons can be used to protect yourself against predators as well, but that's probably not really like the driving selective pressure behind a lot of weapons. And so I suspect that it's probably something similar with ankylosaurs, and it's something that I'm hoping to investigate in a bit more detail as I keep doing my research. So a lot of what I've been doing lately is looking at how weapons evolve in ankylosaurs and other dinosaurs and other extinct animals like glyptodons. So that's been a lot of fun as well. But it's tricky to tease some of these things out in extinct animals.
Yeah, glyptodonts. Those are those like giant armadillos with a spiky type tail club.
Yeah,
thing.
that's exactly right. One of the papers that I'm working on right now is taking a look at what sort of correlations are there associated with having a tail club. So what do ankylosaurs and glyptodonts have in common that might help us understand why they evolved these really bizarre tails? Because tail weapons are really rare. Not very many animals ever really use their tails in combat, especially in modern animals. And there aren't really any modern animals that have like specialized weaponry on their tail. So something like a tail club, or say like the spikes on stegosaur tails. So it's really only in a couple of things, and they're all extinct. So makes it a sort of fun challenge to try to figure out like what's driving like tail weapon evolution, and what sort of led to this very similar structure in these two totally unrelated groups of animals. Because of course, like you said, glyptodonts they're just big armadillos. They're just really big, weird armadillos, basically. Weird armadillos that like have inflexible carapaces and short skulls, and they're herbivorous, but they're just giant armadillos, and they evolve these really weird tails that are similar to ankylosaur tails, even though they sort of do their tail clubs in a slightly different way. It's still a really similar structure in two totally different groups of animals.
Yeah. Do you have any opinions on why more animals don't have these tail defense mechanisms?
Yeah, so this is still research that's kind of in progress, so it might change a little bit as I finish it up. But some of the things that seem to be sort of statistically significant for having a tail club, that seem to be correlated with it and need to be there first in order to have a tail club, are things like being really big and armored. So that's probably not surprising, but those things seem to need to be in place first before tail weaponry can evolve. And today we don't really have any big armored animals.
Yeah.
There are armored animals out there like armadillos and turtles, but none of them really get to sort of truly gigantic sizes. And so that might be like a major reason that we don't have tail clubs or other tail weaponry around today, because we just don't have like big armored animals.
Interesting.
Like at all.
Are there more ankylosaurids, or are ankylosaurids generally bigger than nodosaurids?
No, actually, if I had to hazard a guess, and I need to double check this, but I think that nodosaurids actually are often a little bit bigger than ankylosaurids.
Oh, interesting.
But they're all really big. So
Yeah,
we're sort of like splitting hairs a little bit there, I guess.
Yeah.
So the very biggest ankylosaur ever, I'm pretty sure, is Ankylosaurus out of all ankylosaurs. It's a really big animal. It just has a huge head, and it probably had a huge body as well, although we don't have as many skeletons of it.
Mhm.
But some of the nodosaurids that we find in the late Cretaceous, like Edmontonia, are also really big animals, and I think they're probably at least a little bit bigger than the ankylosaurids that lived at the same time, things like Homalocephale.
Hmm.
Yeah, so if I had to guess, I would say that nodosaurids might sort of edge out most ankylosaurids, except Ankylosaurus.
Okay, that's interesting. You mentioned a little bit about the keeping the tail off the ground. I've noticed that recreations of ankylosaurs or whatever articulations have been presenting the tail like slowly higher and higher off the ground.
My favorite illustrations of ankylosaurs are when ankylosaurids are shown with their tail like in a scorpion position.
Oh, nice.
Like over their body, like pooping like a tyrannosaur on the face or something. I have a really, really funny collection of images of ankylosaurs fighting other animals in really weird ways that don't really make any sense. But yeah, so I'm not sure if they get higher. I think ankylosaurs are really interesting because, yeah, like the tail is really heavy and it's heavy far away from your body. So if you think about, if you ever do like weights or anything and you try like holding even just, maybe this is just me, but if I just hold like a 15-pound weight like away from my body, like out to the side, I like can't do it for very long.
I don't think
because
you're
it's
alone.
hard. Yeah. Okay, that's good. So it's really hard. I can do like one and then I'm like, oh god, my arm like falls off. So yeah, so it takes a lot more like muscular energy for us to hold a heavy weight like farther away from our body. And it kind of makes you wonder, is it the same thing in an ankylosaur tail? Because these tail club knobs are really heavy and their tails are pretty long. Not as long as like a sauropod tail, but they don't have like even really ceratopsians have kind of short tails, and ankylosaurs still had like proportionately long tails.
Mm-hmm.
So one thing that I think might be helping a little bit with them not having to use like muscular power to keep the tail off the ground is this really intricate series of ossified tendons that run along the tail club. So ossified tendons are tendons like we have in our body, but they become ossified like bone. So a good example of something like that is in turkeys. This is great because in Canada we're having Thanksgiving this weekend.
Nice.
But in turkeys, or in like chickens, when you eat the sort of drumstick piece, and there's always that like really thin like toothpick bone in there. Part of that is an ossified tendon. So. And I think it's all, that's the fibula really reduced, but there are ossified tendons in turkey legs and a lot of bird legs, actually. So, yeah, so ossified tendons are something that we find in a lot of dinosaurs, especially a lot of herbivorous dinosaurs, but usually they're more sort of like over the back and over the front of the tail. And in ankylosaurs, they're all way down at the tip of the tail and running along that stiff part of the tail club handle. So I think that what's probably happening is the ankylosaur uses sort of like muscles to keep the tail in the front up off the ground, but then it's probably relying at least a little bit on those ossified tendons to keep the tail from dragging like really heavily on the ground, and maybe also using it a little bit in terms of swinging the tail from side to side, because the ossified tendons can sort of store elastic energy as well. And that's something that's a little bit harder to model when you're doing sort of like mathematical modeling your tail club.
Yeah.
Yeah, so I think the ossified tendons probably play a pretty key role, although it's a little bit harder to actually like test that and study it in a meaningful way.
Yeah, it makes a lot of sense. I figured there had to be some kind of internal structure. I have a background in engineering, so I'm always looking at things, imagining the stresses and forces involved.
Right.
And yeah, that's...
You'd like doing this kind of work then. It's really fun.
Yeah, it's interesting.
Yeah, so it's yeah, I also am not totally opposed to the idea of ankylosaurids maybe having their tail club touching the ground at least sometimes. We don't have any evidence for that, and although there are ankylosaur trackways, they're probably mostly nodosaurids, or at least ankylosaurs without tail clubs, and they don't drag their tails. We don't see tail drag marks in nodosaurid trackways, so it's a little bit up in the air whether or not ankylosaurids would have done that, but I don't think it's too crazy that they might have at least like rested them on the ground sometimes. Again, because they're like pretty heavy, and especially as they get bigger and bigger, they might droop a little further. I wouldn't be too surprised.
Yeah. Interesting. Just out of curiosity, why do you think more animals or dinosaurs don't have osteoderms or some kind of armor?
Ooh, that's a good question. So osteoderms are bone, and bone is really expensive to maintain in your body. Osteoderms are like special bones that form in the sort of lower level of the skin, the dermal layer. So that's where osteo means bone and dermis refers to skin. They're basically skin bones. Humans don't really have anything like that, but it's not uncommon in other animals. So it's the same thing that forms the shell of armadillos. Turtles have osteoderms oftentimes in their arms and legs, but their shell is not osteoderms. It's actually their ribs. Crocodiles have osteoderms, and some lizards, like Gila monsters or Gila monsters, have osteoderms as well. The beaded lizards have them. Mm-hmm. So it's something that we see sort of in lots of different groups, but not in every member of all of those different groups. Because again, like most mammals do not have osteoderms. So it probably has to do with the trade-offs in sort of maintaining a lot of extra bone on your body and all of the like minerals and like resources that it would take to both grow those and keep them maintained. So sort of trade-offs between the cost you have to put into it and the benefit that it does for you in terms of, say, like not being eaten or whatever other functions osteoderms have. So osteoderms have a couple of different functions that we know of in modern animals. They do offer protection against predation, especially when you're very small. It makes sense, but there's actual evidence behind that for like certain lizards. Like the thicker and more osteoderms you have, the less likely you are to be eaten.
Okay.
In crocodiles, they seem to also have a thermoregulatory function. So they seem to have a bit of a function in both like absorbing and dissipating heat, which is very interesting.
Yeah.
Because they have blood vessels in them. So that kind of makes sense. And then a paper that was published recently also shows that they act as calcium storage sites. So when crocodiles are getting ready to lay eggs, they pull calcium out of their osteoderms before they pull it out of other bones in their body. So they can also seem to act a little bit as like calcium reservoirs for animals that lay eggs. So osteoderms probably have a lot of different purposes, and in certain dinosaur groups, they probably also served as, again, visual displays. So it's hard to argue that the plates of a stegosaurus, which are osteoderms, don't have any kind of like visual signaling system or function, because they're so big and like flamboyant. They surely must have some sort of like that's probably what those are for. Mm-hmm. And maybe some ankylosaurs are similar. So some ankylosaurs have very like flamboyant, ostentatious osteoderms, like huge spikes at the front of the shoulders or like large, big triangular plates along the sides of the hips. So those probably have a little bit of a defensive function, a little bit of a thermoregulatory function. Maybe they're also working as calcium reserves, but they might also be visual signals as well. So they probably have lots of different functions. And then it's just sort of a matter of like the trade-offs of any one or all of those functions combined versus, again, the energy you have to put into maintaining them.
Okay. Yeah, that makes sense. That kind of reminds me, there was this paper, I think it was this year, that talked about these large pits that ankylosaurs would get in their osteoderms. Did you happen to see that?
I'm not sure I've seen that one, but ankylosaur osteoderms do often have like really weird textures. They're really like bubbly and knobbly. Some of them seem to have pathologies in them. But yeah, some of them sometimes get these really big pits in them. And I think that it's really interesting. But I haven't read the paper related to that yet.
Okay. Yeah, I was wondering if maybe that was part of it. Like there's a risk for infection that comes with osteoderms or something that would make it so that not all animals wanted them.
I don't know. I mean, osteoderms are still covered, so they're bone, but they're not like exposed bone.
Yeah.
So they still would have been covered by like a scale, like a sort of like a horny, like keratin scale in life. Not very many animals have just like straight up like exposed bone. I think one of the best examples is antlers, but antlers are really weird. So yeah, like they would have been covered by some sort of like horny covering. So I don't think they'd be at risk of infection like more than other parts of the body. Unless, of course, maybe they're harder to heal if they get bitten or damaged or something like that. But that I am not sure of.
Yeah, I think in the paper there was some particular bacteria or something that they were guessing might have gotten into it through like either a bite or some other mechanism, and then it spread or something like that.
Interesting.
It is interesting.
Yeah, I'll have to check that out.
Yeah, I just found it. It was in the Journal of Paleopathology.
Ooh, that sounds fun.
Yeah. Yeah, I think it's the only article I've ever read from that journal, but I need to check it out more often. So, on a lighter note, getting away from paleopathology, I know that you helped out the group making the game Saurian on their virtual Ankylosaurus model.
Yeah.
Are there any features that you kind of encourage them to include or that you're particularly excited that are in their version?
I'm really excited about Ankylosaurus because I think that together we came up with like the best, most accurate reconstruction of it that's out there today. It was really nice working with them because the first draft they sent me, I had a lot of comments about, and they were totally willing to not because they had done a bad job, just it's hard because there's not a lot of information out there, even though Ankylosaurus is such a household name. There isn't a lot of information out there. There's a couple of papers, but there aren't like skeletons in museums to go look at. So I had a lot of comments, and they were really great about just running with it, and we sort of totally retooled it, like gave it a whole new sort of osteoderm arrangement, like new interpretations. So I'm really excited because I think it just looks great. I think it looks like a real animal, not like some kind of like smudged together monstrosity that Ankylosaurs sometimes look like because they're hard to interpret and they don't really look like anything around today. So it's kind of hard to they're not like intuitive animals to reconstruct. And the osteoderms are a lot of work for artists to work on. So yeah, so I'm really excited about that. And then it also was voted one of the new playable characters. So after they've released the sort of first release of the game, it's going to be the next one that becomes one of the sort of characters you can play from a baby up to an adult.
Yeah.
So I'm really excited to be working with them on sort of taking what I know about ankylosaur behavior and growth in general and applying that to make sort of like a cool story for Ankylosaurus. So
Nice.
I'm really looking forward to it.
Yeah, me too. I voted for Ankylosaurus with our Kickstarter vote.
Oh, nice. I did too.
Excellent.
But I'm probably a bit biased.
Yeah.
Yeah, so I think it's going to be really fun. And I think I'm actually not someone who plays a lot of video games because I tend to get like very motion sick from a lot of especially like 3D video games. But I've been really excited to work on this and sort of try this new medium of scientific storytelling because it's a little bit different than say like a television documentary or even like a university course because the players get to make decisions about what they're doing as those dinosaur characters. So I think it's a really neat way to get people sort of more immersed in the science behind dinosaur research as it is today. And it's just like a cool medium to be helping out with. So I'm looking forward to it.
Definitely. It's too bad that you say you get motion sick because they are going to make a VR version too.
I definitely will not be able to play that one.
Yeah.
But I'm looking forward to trying this one out. And I might just have to do it in little bits, but I think it's going to be really good. I think it's going to be a lot of fun.
Yeah. I like the colors that they chose too. Or did you have any impact on the orange and brown theme that they
a little bit. So they came up with a couple of different like alternative options and then asked for my feedback on them. And yeah, I like going with sort of a brightly colored ankylosaur. I sort of like the sort of high contrast that like it's sort of dark, but then it's got these like bright patches on the rest of the body. So I think that looks pretty cool. I wanted to move us away from like brown ankylosaurs.
Yeah.
So they don't necessarily need to be like neon colors, but I think they're real animals, and animals have different kinds of color patterns based on behaviors and environment and all kinds of things. So yeah, why not have a nice colorful ankylosaur?
Yeah, and especially when you mention the porcupine analogy, if animals are just going to avoid it because they recognize it as something you can't really mess with, it makes perfect sense for it to be brightly colored because then, you get the mating display to go along with it.
Right. And yeah, a lot of animals use like warning coloration or at least warning patterns, sort of bright contrasting patterns to sort of indicate danger. So yeah, I mean, we don't really have any evidence for this in ankylosaurs, but I think it seems pretty plausible and reasonable. Yeah, and nicer than just having sort of like a regular like dirt brown ankylosaur that's kind of stupidly, so.
Or green, like a
Right,
lot of depictions.
Yeah. And I mean, I'm sure some were green, and like that's fine. But a lot of a lot of ankylosaur art doesn't sort of portray ankylosaurs in a very like favorable light. They're often like just kind of standing there, not looking particularly smart.
Yeah.
Or falling off cliffs is a thing that keeps happening
Really?
also in ankylosaur art. So I have like multiple examples of ankylosaurs just like falling off of hills, and I'm like, oh man, they're
That's
not that
weak.
stupid. Like,
Yeah.
I mean, they're probably not like super smart animals, but they probably could avoid falling off of cliffs like some of the time.
Yeah. They have a low center of mass. They'd be good at
Right.
like not falling.
Right. Yeah, it's just like a funny thing that keeps showing up. I don't really think I've seen that with other dinosaurs very often, so it's just like a weird, I don't know, it's just a weird thing. Weird thing about ankylosaurs.
That is weird. Cool. So, just as like a kind of final researchy question, is there anything else that you're excited about, that you're researching or looking forward to?
I have really cool things on the go that I can't really totally talk about yet, but
Okay.
I hope that any listeners will stay tuned for cool ankylosaur stuff in the next couple of years. I just started a new postdoc at the Royal Ontario Museum. I was previously at the North Carolina Museum of Natural Sciences. So I have some really cool things I'm finishing up there related to weapons research and how dinosaurs evolved weapons. And some of my focus at the Royal Ontario Museum is going to be a bit more on like patterns in dinosaur biogeography. So looking at ankylosaurs, but also looking at like groups besides ankylosaurs and sort of understanding like how sea level and climate and land bridges and different things like that influenced how they dispersed between North America and Asia during the Mesozoic period. And I think that's going to be really cool because I think we're going to be able to learn some really interesting things about what sort of like environmental and biological factors influence broad scale migrations between continents. So I think that's going to be really cool too.
Does that tie into your research about the ankylosaurs swimming?
Yes, a little bit. I hadn't totally decided to take this direction when I wrote that paper, but that paper sort of gave me a good impetus to sort of further investigate some of these things. So in that paper, I had taken a look at a pattern that had been noted by other paleontologists before, that nodosaurid ankylosaurs seem to wind up in marine sediments more than ankylosaurid ankylosaurs. So I took another look at that, with some of the new species that we've identified and new specimens, and did some statistical analyses and found out that, yeah, they do wind up in marine sediments more often than ankylosaurids, but not everywhere and not always. So it's mostly in North America that we see that particular pattern, and that's probably because North America keeps getting flooded by the huge Western Interior Seaway. So that seaway has a really big influence on ankylosaur diversity during the Cretaceous period, because at least from the data that we have right now, it seems like North America had its sort of own like homegrown like group of ankylosaurid ankylosaurs and nodosaurid ankylosaurs. But the ankylosaurids actually go extinct as the sea level gets really, really high in the middle of the Cretaceous. And so most of the ankylosaurids, the ones with tail clubs that are really famous from North America, like Ankylosaurus and Homalocephale, are actually Asian immigrants that came in much later and sort of recolonized North America. So it's really interesting to see how things like sea level, and hopefully we'll take a look at, say, like temperature, or maybe even things related to like diet or body mass, might sort of influence sort of like extinction events in different clades or dispersal events in different clades, and just sort of help us understand like the pattern of dinosaur evolution in North America. And maybe we'll even learn a little bit about what's in store for us as climate changes and sea level rises nowadays. So I think it's going to be a really cool project.
Yeah, that sounds really interesting. I'll have to keep my eyes peeled.
It's going to be a little while, though, because I just started, but I am excited.
Great. Well, thank you so much for talking to me. If people want to learn more about you or your research or follow you, should they go to Twitter, or where should they go?
Yeah, I think Twitter is probably the best place, and my Twitter handle is really simple. It's just my name, so @VictoriaArthur.
Great. Yeah, you post lots of things. I think I retweeted something you posted today that I liked a lot.
Oh, yay.
Part of your, what'd you call it?
Drawloween.
Drawloween, that's what it was.
Yes,
yeah.
That's a fun thing that I'm doing, mostly just for fun, but a lot of them are winding up having dinosaurs too.
Yep.
So that's been pretty fun.
Yeah, and kudos on the great artwork. I liked all of them so far, actually.
Oh, thanks. That's so nice of you. Thanks.
Cool. Thanks again to Victoria for speaking with us about ankylosaurs, since they're obviously the best dinosaurs.
I don't know about the best, but they are pretty cool.
They got the scutes.
Yeah, that's true. Thanks again, Victoria.
Before we get into the dinosaur of the day, we have another word from the Royal Tyrrell Museum. The Royal Tyrrell Museum is one of the largest and most respected paleontology museums in the world. The museum takes you on a journey through time that brings you face to face with some of Canada's mightiest dinosaurs. With 9 ever-evolving galleries, fun hands-on activities, and the rugged beauty of Alberta's badlands that yield the greatest diversity of dinosaur fossils in the world, there's something for everyone. One of the things that Sabrina and I really like looking at different natural history museums are their preparation labs, and the Royal Tyrrell Museum has a pretty massive one. Compared to some other museums that often only have enough space for like 1 or 2 paleontologists or maybe 1 or 2 pieces to work on at a time, the Royal Tyrrell Museum must have had at least 8 or something stationed. It's like you're looking into a whole part of a warehouse or something. It was enormous.
Yeah, it was.
And there's, a huge glass window in front of it so that you can see into this whole area. And they have all sorts of tools everywhere and those little elephant trunk thingies to exhaust fumes and dust that comes flying out when they're using their little dental tools and everything in their preparation work. And when we were there, they actually had one of the scientists outside of the preparation lab sitting working on a tiny specimen, kind of in a really small scale setting so that you could see the detail.
We could see up close, and I think she let us touch it.
Yeah, I don't remember.
I'm going to say she did.
Okay. Yeah, the preparation lab, though, is really cool. And on the Royal Tyrrell Museum site, they point out that during the summer, most of the paleontologists are out doing field work and things like that, so the preparation lab doesn't have quite as much going on. But now that we're getting into the fall and winter season, when you don't really want to be out digging outside in Canada, they bring most of the work inside and they start preparing the fossils that they excavate during the summer. So now's a good time to go there and see some preparation work starting to happen. And if you're looking to support paleontological research, you can join the museum's membership program, which supports its scientific research, exhibits, and educational programs, and offers unlimited admission to the museum. More information can be found at tyrrellmuseum.com.
And that's TYRRELL museum.com.
Yep. Sabrina's the resident speller.
I guess so. And now on to our dinosaur of the day, Homalocephale, or also, depending on who you ask, Prenocephale. And this was a request from Jill via Patreon, so thanks, Jill. The name Homalocephale means even head, which is pretty funny. It's a pachycephalosaur that lived in the late Cretaceous in what is now Mongolia, and it was described in 1974 by Osmólska and Maryañska. There's only one species, the type species, which is Homalocephale calathocercos. And as we said earlier, it may be a synonym and juvenile form of Prenocephale. But the Homalocephale type species is an incomplete skull and postcranial material. It had large openings on the top of the skull and a large round eye socket. Scientists described it as an adult originally, even though it had juvenile traits like a flat skull or even head. Then in 2010, Nick Longrich and others said it may just be a juvenile version of another adult pachycephalosaur. Horner and Goodwin also suggested that in 2009, and Longrich was the one who suggested it was a juvenile or subadult of Prenocephale. It was an herbivore about 6 feet or 1.8 meters long, and it had this flat, wedge-shaped skull roof, though the skull was pretty thick. And this is similar to Dracorex and Goyacephale and not similar to other adult pachycephalosaurs. It had a broad pelvis. Some paleontologists think it may have had wide hips to give live birth. Others think the wide hips helped protect organs during flank button elo.
I like the idea of dinosaurs giving live birth.
Me too.
That'd be cool.
Yeah, ever since our interview with Dave Verricchio, I've been thinking about the possibility of live birth. It's pretty cool.
Yeah.
Homalocephale had long legs and was fast, and probably had a very rigid tail. And you can see it in the game Jurassic Park Operation Genesis, where you build your own Jurassic Park. So now, moving on to Prenocephale, the same people who described Homalocephale described Prenocephale in 1974, the same year. It's Maryañska and Osmólska.
Awfully suspicious, one might say.
And so the name Prenocephale means sloped head. Must have had very distinct heads.
Yeah.
It lived in Mongolia in the late Cretaceous, and fossils found include skulls and fragmentary postcranial remains. There's 3 species. There's Prenocephale prenis, Prenocephale brevis, and Prenocephale edmontonensis. And the type species is Prenocephale prenis. There's another suggested synonym to Prenocephale, in addition to Homalocephale, and that's Spherotholus. Prenocephale was an herbivore, about 7.8 feet or 2.4 meters long and weighing 280 pounds or 130 kilograms. Prenocephale had a round, sloping head with a row of small, bony spikes and bumps. It was thought to have a stout body with a short neck, short forelimbs, and long legs, and this is based on other pachycephalosaurs since all that's been found in Prenocephale is mostly skulls. Some scientists think Prenocephale may have been an omnivore that ate plants and insects, though many think that it ate leaves and fruit. It was probably a selective browser since it had a narrower snout than other pachycephalosaurs. And pachycephalosaurs, as we've talked about a lot, may have headbutted or they may have used their domes to attract mates. Teenage or young adult pachycephalosaurs were best equipped to handle headbutting. The skulls had radiating structures that compressed, which provided cushion during a fight. And adults didn't have these structures. In June 2011, Eric Snively and Jessica M. Theodore published in PLOS One, and in this study, they compared Stegosaurus and Prenocephale skulls with headbutting mammals like elk and muskox with CT scans. They found Stegosaurus and Prenocephale domes were most similar to muskox and duiker. And interestingly, Stegosaurus was most able to headbutt. In July 2013, Joseph E. Peterson, Colin Dishler, and Nicholas Longrich published in PLOS One, distributions of cranial pathologies provide evidence for headbutting in dome-headed dinosaurs, Pachycephalosauridae. And this team studied 109 domes from 14 species to see if there was evidence of headbutting. 22% of those domes showed evidence of osteomyelitis, which often comes from skull trauma. Because there was evidence of this, a lot of evidence of this, they concluded it was consistent with the idea of intraspecies combat. They also looked at 30 skeletons of headbutting mammals and found that, quote, comparisons with injuries in extant bovids illustrate the variation in injury and lesion distribution related to behavior and suggest that the distribution of injuries in extinct animals can therefore be similarly used to infer behavior in extinct taxa, end quote. So, a lot of evidence that Pachycephalosaurus did headbutt, which we know has been a big debate.
Yeah. And a lot of that does come down to you don't know exactly what they were headbutting, if they're headbutting each other directly head to head, or if they're hitting each other in the sides or what.
Well, it sounds like Peterson and his team concluded that it was them doing intraspecies combat, so they were going head to head.
I don't know if it's head to head though, because intraspecies combat could still be like flank butting or whatever.
Oh, that's true. That's true. You could still have skull trauma for that.
Yeah, but it's really hard to figure this stuff out just from bones.
But the study is called headbutting in the name, so.
Headbutting doesn't necessarily mean they're butting head to head, though.
Oh, that's true.
Yeah. It's tricky.
It is. Those pachycephalosaurs. So Pachycephalosauri is a clade of ornithischians, and the name means thick-headed lizards. They lived in the late Cretaceous in North America and Asia, and they were bipedal and, of course, had thick skulls.
And our fun fact of the day goes back to ankylosaurs because, of course it does, since they're the best.
They're not the best.
I think they are. So ankylosaurs were the most heavily armored dinosaurs, and they weighed up to about 6 metric tons or 13,000 pounds. On the other hand, the glyptodont Doedicarus is probably the most heavily armored animal since the Pleistocene, which was like that period 2 million years ago-ish. And they could weigh over 2 metric tons and over 5,000 pounds. Unfortunately, they were probably hunted to extinction about 11,000 years ago by humans in South America.
Oh.
Yeah, they would have been really cool to see because they were about 1.5 meters or 4.9 feet tall, 4 meters or 13 feet long, and they had a big mace-like club tail to go with their armadillo-like body armor.
Wow.
So it would have been quite a thing to see. They're pretty common in natural history museums and things like that since they were around until so recently.
I could see why you'd want them, though. That's a lot of meat.
Yeah, it's like eating a huge turtle.
Mm-hmm.
Although, I think armadillos are the main place people get leprosy from. So, I wonder if glyptodonts also had leprosy.
I have no idea. Interesting.
Another fun fact. That was a little bonus.
Yeah. And that wraps up this episode of I Know Dino. Thanks for listening. Again, we invite you to celebrate with us for our 100th episode. Support us on Patreon at patreon.com/iknowdino. We promise we'll do a great shout out of your name in our video.
Yeah.
Thanks again, and until next time.
Thank you for listening to I Know Dino. If you have any questions or comments about dinosaurs, we'd like to hear from you at plesiosaur@iknowdino.com. And for more information on dinosaurs, go to iknowdino.com or follow us on Google, Facebook, Tumblr, or Twitter at I Know Dino.